Hello, everybody, and welcome to yet another lesson for contemporary math. This lesson we will be going over section 4C. And in section 4C, we will be looking at savings plans and a few examples. So I say we jump right in. Before I get to any of the equations on this page or anything on this page, like this monstrosity here. There we go. It looks like my pencil's working now. Okay. I want to explain what we have been talking about up until this point regarding finance. Before watching this video, or rather in previous videos, we've been talking about having a one-time investment, and you hope that if you're only making a one-time investment that you make a very large investment, like thousands upon thousands of, like $30,000 investment. Well, if you're like me and most people, you just don't have $30,000 sitting around to invest. So we have to look at how savings plans work. So savings plans allow us to save $30,000 of our own earned net income, but over the course of 4 years or something like that. So you don't have to have all the money right up front. And so when we do that, the formulas start getting much more complicated, as I alluded to earlier. We still have very similar ideas and very similar feeling to these. It's just now a little, like in a little bit of a different context. So before I even get into any of these variables, what they mean, I bet you can look over here at this equation and say, wow, this right here looks a lot like the compounded monthly, or the compounded quarterly, we'd say the compounded nthly formula. 1 plus APR over n, all raised to the ny power. That is a formula you've seen before. So what we're doing to that, and what did we do to it? We multiplied it by p. In this case, we're going to call it payment. P means just one time, a one-time payment, whereas PMT here represents a regular payment, a deposit amount that you'll do every period, be it month or week or every quarter, something like that. So we have an equation that almost looks like P times 1 plus APR over n to the ny power. The only thing that we're adding to it then, or adding to the formula I should say, is this minus 1, and we're dividing by another APR over n. So everything here already should make a lot of sense to you. You should understand what these variables mean. All right. Let's jump right into an example, and I'm going to do as much work as I can in this space here so that I can keep this formula in view. So here we go. We have Mandy. She just secured her first job after completing college. Good for her. She is saving to buy a car. If $500 of her monthly paycheck is automatically deposited into a savings account having an APR of 2%, how much will she have in 5 years? So we know what her payment is. So I'm going to treat this just like we did any other example in previous videos. I'm going to write off to the side. I'm going to write my A, my PMT, which used to be P. I'm going to write my APR, I'm going to write N, and I'm going to write Y. Cool. All right, so we don't know how much money she's going to end up with, so we'll leave that one blank for now. We know it will be a $500 payment. We know the APR is 0.02 as a decimal. Let's see. We have a clue here that says monthly. That's how we know N will be 12 and Y is 5 years. Here it is. So what we're going to do is we're just going to fill in this equation up here with all of these numbers. Like this. So here I have this all done up, and this is a lot to handle right now for me. So I want to simplify a few things here to make it a little easier to understand what the heck is going on. So the first thing I want to do is I want to notice that in this exponent, I have 12 times 5. I want to take care of that multiplication as quickly as I can, so I only have one value up there instead of 2 being multiplied. So 12 times 5 is 60. Now the other thing that I see in this equation that gives me a little bit of pause and a little bit of anxiety, I guess, is this fraction, 0.02 over 12. And in fact, it's in the equation twice. So I want to figure out what that is. 0.02 over 12 will be equal to 0.0016666. And those sixes just go on forever. So I like going out a lot of decimal places. Go out as many as you can stand to write. That way you have a super accurate answer. Well, now, if I use these values in this equation, I can see that the equation gets pretty simplistic. I will have this. So from this equation here, I think the correct way to do things is you want to figure out what 1.0016666 to the 60th power is. So do that first. Then subtract 1. Then you want to divide it by this number. We'll say that's third. And then lastly, you can multiply it all by the payment. So I'm going to figure that out very quickly and be right back with an answer. And if you are doing all of these calculations correctly, you'll get that Mandy will be saving $31,000. That's a lot of money. $523.62 if you round up. So Mandy's going to have a nice chunk of change there to put a down payment or just outright buy a car. And y'all, this is with a 2% interest rate, which is very achievable. So I'm just curious now, if you were to put $500 a month into an envelope and store it at your house and not make any interest on it, how much money would you have after 5 years? Well, that calculation is a lot easier because we don't have interest to deal with. So you would take your payment, I'm going to do this in yellow. So you would take your payment, you would multiply by how many payments you would be saving, right? $500, 12 months a year for 5 years. And that would give you $30,000. So yeah, you can see that you don't make as much money if you just put it in your safe or under your mattress. The bank, having money in the bank will earn you more money. It's $1,500. That's almost $300 extra per year for no extra work. That bank is just giving you this money for free. Let's see what happens though if we increase that interest rate to 8%. So I sort of skipped the page upward there, but that's fine. If you were to raise this to 8%, your equation would look a little different. It would look like this. Here's what the equation would look like. That's 1 plus 0.08 divided by 12 raised to the 60 power, right? That exponent wouldn't change. It's still monthly for 5 years. It's still an exponent 60. Minus 1 all over 0.08 divided by 12. If you figure out 0.08 divided by 12, you will get this number right here, 0.006666665 So then what you would do is you would replace these fractions with this number and follow the calculation steps here. Start with the power being raised to the exponent, then subtract 1 from that, then divide by this decimal again and multiply by 500. And I think you all are going to be shocked at how much money you get. So I'm just going to make that calculation and I'll put it right here. We will say the total amount at 8% interest rate will be $36,000 plus another $738.43. So now you can see that with a higher interest rate, I think this is where most people understand how money works. If you have a better interest rate, you will make more money. So between just stuffing it under your mattress and having 8%, you make an extra $6,700 in those 5 years, which is almost $1,350 per year for free that you are just making for having your money in a bank. It absolutely makes sense for you to have money in a bank or invested somewhere. Something else, I'm going a little off script here, 8% is roughly how much the stock market grows each year. That is through recessions, that is through depressions, it just grows about 8% per year. So if you put your money in the stock market, it'll grow like this. $500 a month for 5 years. Your $30,000 will eventually become $36,000. And it can just grow exponentially from there. It's crazy. All right, back to it. A little savings vocabulary. So here we have 5 definitions, and the first being an annuity. So an annuity is any series of equal regular payments. So these two words mean different things. Equal means the payment will be the same amount every single time. Regular means they will happen at the same time interval. So if you make quarterly payments, you will always be making quarterly payments. If you make daily payments, you will always be making daily payments. So those are what the 2 things we need in order to have an annuity. From there, we can break annuities down into 2 different categories, an ordinary annuity and an annuity due. So an ordinary annuity would be like your electric bill. If you have your electric bill on average billing, which means you just pay the same amount for your electricity each month, this would be payments that are made at the end of each month or at the end of each payment period, right? The electricity company doesn't know how much to charge you until you use the electricity. So you make the payment at the end. An annuity due is a payment you make at the beginning of each payment period. So an annuity due, an example of that would be like rent. If you are living in an apartment, you have to pay to live in that apartment, and then you live the next month in that apartment. At the beginning of the next month, you have to pay it again to live for that month. So then we just have a couple other words here. The future value of an annuity is an accumulated amount at some future date, and the present value of a savings plan is a lump sum deposit that would give the same end result as regular payments into the plan. So that's just, we're looking for the accumulated amount or we're looking for the present amount. So A or P or payments. Let's take a look at how we can use all of these and some examples on the next page. So here we have Brandon. Brandon is 24 years old and starts an IRA, which stands for Individual Retirement Account, to save for retirement by depositing $400 monthly into an account offering an APR of 6%. Cool. How much will he have in the account if he retires in 40 years? So I just want to stop there. Let's figure that out first. Brandon is 24 years old. He's going to work for 40 years. And for each month, he is going to put this amount of money into an account that earns this interest rate. So let's set up the formula that we had from the other side, from the last slide. So here we have a setup. We have A equals the payment, square bracket parentheses 1 plus the APR over 12, that's monthly, close parentheses raised to the 12 times 40 power, NY power, minus 1 all over this fraction. So this fraction is 0.005, there it is. This exponent becomes 480, I miswrote that there, 480. There we go. And the grand total for this particular annuity will be $796,596.29, and that is a huge chunk of money. So if we figure out very quickly here, what is the total number of deposits Brandon made along the way? Well, we know Brandon is putting $400 per month in, per month, and there are 12 months every year, and he's doing it for 40 years. That means Brandon put into his account $192,000. So like from this little bit of money, I use that word lightly, it grew into that large amount of money. So the question then becomes, how much interest did Brandon make? Well, that's simple. You just have to find the ending amount and take away the total number of deposits. So if I write $796,596.29 and take away $192,000, you'll see that Brandon made $604,596.29. And I'm going to do a very quick live calculation here. 604,596.29. He saved that for 40 years. That is $15,000 per year in interest this guy earned if you average it over every of the 40 years. Y'all, that's $15,000 per year that your money just made sitting there in this investment. You don't have to have a lot of money up front to have a lot of money at the end. You can make normal payments every single month, but you have to be disciplined to do it. All right, let's take a look at this next scenario. Mr. Smith is getting a late start, but at the age of 50, he also hopes to retire at the age of 64. If he deposits $1,200 monthly into an IRA, still with the same percentage, how much will he have in the account when he turns 64? So Mr. Smith is going to put 3 times the amount per month into an account, but he is only going to be doing it for, 14 years. 64, he wants to retire, he's 50 now. So let's set up Mr. Smith's scenario. Okay, so I laid out all of Mr. Smith's information. We don't know how much money he'll have at the end. We know that he hopes to retire at the age of 64. He is tripling the amount of money he's putting into the bank each month over Brandon. And in fact, I didn't mention this, but he's only going to do it in 14 years, which is about 1/3 of the time that Brandon did it. So tripling the amount of your payment and taking 1/3 of the time, you would think would quote unquote cancel each other out and give them the same amount of money at the end. Well, let's see what happens. I was able to use 0.005 because we knew that Mr. Smith was earning the same APR and making monthly deposits. So this fraction would have been the same for Mr. Smith over here. So I just borrowed this information from Brandon to do this question. So if we raise 1.005 to the 168 power, subtract 1, then divide by this decimal and multiply by 1,200, the total amount Mr. Smith ends up with is, I think it's $314,000. Also 765.72. There we go. $314,765.72. This is how much Mr. Smith ends up with. Now, how much interest did Mr. Smith make? Well, we have to find out his total deposits. So his total deposits would have been 1,200 times 12 times 14. So he would have invested $201,600. So Mr. Smith invested more money, deposited more money into the account than Brandon did, and still ended up with less. And that is exactly why I got done saying in the last lesson, make sure you invest now, you invest early, you invest often, you invest consistently. So you have, when you have the time for that money to grow, it is the most powerful factor in growth. So just to round this question out, Mr. Smith will have interest of $113,165.72, which is nothing to scoff at. Over a 14-year period, maybe that's like $8,000 or $9,000 a year. But I'll tell you, that's not the same as getting $15,000 a year for 40 years. Brandon is going to be much better off in retirement. All right. So with this next example and grandma here, I am going to slowly reveal some steps about every 5 seconds or so, just so that you can see how this is going to work, because this video is already getting very long. All right, that's a lot of information in a little bit of time. So the first thing I did was I wrote down everything I knew. This time we don't know the payment. So I wrote down the equation here so I could make sure I get every number where it was supposed to go. The next thing I did was I simplified, as I did in the previous example. I simplified the fraction because that same fraction will show up twice. And I simplified the exponent. So then with those simplifications, what I did was I went through and I did exactly like I did in the previous examples. I figured this piece out first, then I subtracted 1, then I divided by this number, but instead of multiplying by the payment, I stopped. So I did this, I combined in here and raised it to a power, subtracted 1 and divided, and I stopped. Because I can't multiply it by the payment this time, we don't know the payment. We're trying to figure that out. So when I stopped with the calculation here, I got 285 point lot of decimal places. So I have the payment multiplied by this 285 would equal $50,000. So what I did from there was I divided by this number so I could isolate the payment. And so I had to divide 50,000 by this number and got the payment was $174.86. And this right now, $50,000 right now, this is 2020, March 27th, 2020. That could pay for a lot of college education. So when you have grandchildren that are being born someday, if you have start saving for them. It doesn't even take $200 a month to grow it into $50,000. And if you do it better than 3%, then it won't take that long. Or if you invest this much at better than 3%, it'll grow to be bigger than $50,000. All right, so one more example. I'm really trying not to be too soapboxy here, but it's just happening. Jerry is earning a great living as a businessman. His dream is to retire comfortably in 30 years, drawing $100,000 per year for the rest of his life off the interest from a retirement fund. Woo, this already sounds difficult. How much would he need to invest monthly to retire in a retirement fund to turn his dream into a reality if we assume the constant APR of 7.5%? So I'm going to release this in steps again. And there you have it. This is a lot easier than you think. So this Jerry wants to have $100,000 per year. So he's just going to get the payment once per year. But he wants that $100,000 to be the interest from his retirement fund. So if we know how much is in the retirement fund, we can just multiply it by the rate and get 100,000. Well, we don't know how much is in the retirement fund. That's what we're trying to figure out. So instead, we have to substitute the number 100,000 in for the interest. We have to substitute P for the principal because we don't know, and we have to substitute 0.075 as the rate. And then we can divide by the interest rate here to show that the principal would have to be $1,333,333.33. And that concludes the lesson for section 4C for contemporary math. All about savings plans and interest and principles and real world usable stuff. I hope this helps you. Good luck.